can start.
Okay.
Over to you, Team MUT. Good luck.
Good morning, everyone. Have you ever considered, have you ever wondered how South Africa, sorry.
Technical team, can you assist with a slideshow? All good.
Okay. Good morning, everyone. Have you ever considered how South Africa's healthcare system serves its own people? Let's explore some eye-opening statistics that bring this picture to life. Okay. 15% of the population uses private healthcare, yet private healthcare consumes a 15% of the population uses private healthcare, yet private healthcare consumes an unfair share of the country's resources. Meanwhile, the remaining 85% depends on the public healthcare system, which unfortunately remains unfunded and struggles to meet demands. This disparity is especially noticeable in rural areas where many people face long travel times to access basic health care and where facilities are often inadequate to meet the population's needs. Our problem is clear: inequitable access to healthcare between urban and rural areas. This issue is rooted in the historical imbalance in resources, where urban areas receive the majority of healthcare services, leaving rural regions underserved. To address this, we need a fair distribution of resources with a focus on rural and underserved regions. Our solution involves data-driven insights, leveraging datasets related to claims, disease prevalence, geographic disparities, and demographics. These insights will help guide the equitable allocation of healthcare resources.
Good morning, everyone. I'm going to take you to the data processing, and also I'm going to take you to the selection of the models. To ensure our dataset analysis was ready for addressing healthcare inequities, we followed sorry about that. We followed a rigorous data preparation workflow. The data was primarily sourced from one of the sponsors, Altron, and we supplemented it with publicly available datasets such as healthcare facilities, data from humanitarian data exchange and population data. Oh, sorry about that. These sources enriched our analysis and supported the development of our robust real source allocation model. So before we went to data modeling, we did data cleaning, where we cleaned our data, made sure that we dropped all nulls, and we also dropped the columns that were irrelevant. We also did feature engineering, whereby we selected specific we selected specific features that we were going to use for our data, for our model development, such as the the provide or the provider practice table. Then going to the data modeling, we chose to use a time series model where we forecast the future. What did it do? I'm sorry about that. I was starting to talk about my next colleague's slides. I'm just going to talk about the data models we selected. We selected forecasting, which is a time series data processing, where the model that we picked was the Facebook Prophets, and we also done regression where we predicted the healthcare facilities required per region. We used the random forex regressor, and then we made some geospatial analysis which mapped the South Africa, the high risk towns in South Africa that were most likely to have the most diseases. I'm gonna hand it over to the next speaker.
For findings and results, we have observed that rural areas suffer from high disease burden while they lack resources. We have used the error matrix RMSE, which gave us the results of 0.74 for our forecasting accuracy. We have looked into the lack of child healthcare claims and providers by analyzing the children healthcare claims and where the providers were located. Despite this, we found a clear difference between healthcare claims and providers where they are located in different regions. This highlights the need to distribute resources equally, especially in those underserved areas. On our next slide, our findings and results continuation, we identified critical regions needing more healthcare services, discovered inefficiency in resource allocation, especially in those rural areas that are underserved. Our findings highlight the differences between resources availability and healthcare needs, especially in the rural regions. These results support targeted interventions for rural areas and suggested ways to balance the resource allocation between public and private sectors. Thank you. I'll pass it to my next colleague.
Greetings to my colleagues. I feel privileged to be here today to elaborate more precise on how did we go about the proposed solution and demo. So with regards to our problem statement that was explained from the beginning, we then came up with a solution of solving it with the use of interactive dashboard, which is a streamlight that is helping us do the visualization of healthcare disparities, help us do the visualization of forecasting patient inflow. It also helps us to see the mapping of the disease prevalence. With regards to data-driven, Streamlight has been very helpful because it also provides us with the insights into the healthcare cost. It helps us with the insights to resource allocations in terms of where are the resources mostly distributed and where are they not distributed enough. It also helps us in terms of the disease burden. With regards to societal impact, we believe that we need to take actions in terms of empowering the policymakers to allocate resources equally to the places whereby resources or to areas whereby resources are not distributed enough, such as the rural areas, as we believe that they are the place that don't receive more resources. We also planning on taking action to improve the healthcare access to the undeserved areas. As I have just mentioned, the rural area is our target. Furthermore, on the demo, we used streamlights to show the interactive elements of the dashboard, showing the overview of how are we going to see the visualization of the healthcare disparities. For our solution, it is an interactive dashboard that helped us do the visualization of the data, also the insights in a user-friendly way. And the dashboard is very useful because it's helped the users to explore the geographical disparities, disease focused, and healthcare spending, helping those decision makers to allocate resources more effectively to the place that is not exposed to resources.
In conclusion, our solution plays a crucial role in addressing, oh, sorry. Our solution plays a crucial role in addressing healthcare inequity by providing valuable insights into resource allocation and accessibility. Thank you for your eyes and ears.
Thank you, Team MUT. So now it's time for questions. The floor is open. Judges, you can go through and ask the questions.
Okay. Thank you so much, MLC. Great presentation. I just have one question. Considering the resource disparities across regions, right? Like, how did you actually account for it? And also, according to your predictive models, how they actually impacted the resource disparity between urban and also rural areas?
Can you please repeat the question?
Okay, so I wanted to know actually how does actually your model or predictive models account for the resource disparities between the urban and rural areas?
So we started off by identifying the regions whereby the the healthcare facilities were at most, and we identified that those those regions were mostly urban. Since this map here shows the regions with the high facilities in green. The blue ones were supposed to show the ones which are in the rural areas. And since we all see here there are no blue ones. So hence that's when we identified that there's an unequal distribution of healthcare resources, and that's when we went about with our problem.
Okay. So you said these which show in green are those which are from the rural areas. That's what you're saying.
No, these ones
Urban
are from the urban.
urban areas. Okay.
Yes.
Okay. Thank you so much. That was my question. Thanks.
Okay, thank you, online judges. Judges in the room, I have one question.
Yeah, so thank you. Yeah, excellent presentation. I also want to pick up on that last point. So here I see you used facilities as determination for um, um, resources, right? So I'm keen to understand maybe one of the strategies, in fact, maybe a consideration for you is to say in rural areas, there could be that the use of community health care workers also becomes a consideration to your model, because that allows not just to, them having to go to a facility which might not be feasible at times because of many other issues. So maybe another consideration to your model is to say, how do you bring in other attributes that will support your model?
All right. Thanks.
Team MUT, did you understand the question?
It was more of a comment. Yeah,
Okay,
yeah, yeah.
cool.
Thanks.
All right, all right. Um, so the last chance of the questions. Let me just check my time. I'm left with 2 minutes for questions. The floor is open.
Yeah.
Okay, I think there's a question in the chat. And then I'll ask my question after.
So the first question is, what matrix are you using to evaluate the success of your optimization model?
We use the RMSE
Can you
matrix.
speak to the mic?
We use the RMSE matrix.
RSE matrix.
Yes,
Okay.
RMSE.
How do you measure the improvement in equity of resource distribution?
Okay. Did you understand the question?
We didn't get the last question, so
Could you please rephrase?
Okay. She's gonna repeat.
The second one.
Yes, ma'am. Could you please rephrase?
How do you measure the improvement in equity of resource distribution?
As we find lower result in the RMSE matrix, that's how we measure our accuracy, because it's close to 0.
Okay. Another question on my side. What does your mean square error tells you about?
The mean ish. I think maybe we forgot to put it on the slide. Yeah, or maybe we didn't evaluate the mean square error.
Did you, okay, have you went through your coefficient of determination?
Sorry, the what?
Coefficient of determination. Okay, it's okay. The time is up now. Thank you for your presentation, MUT. Can you clap hands for them? Okay, guys, we're gonna break for